Welcome to day 12 of the Common Lisp series. In today's video, we are going to animate a sprite. So I don't really have any objective, but we're going to work with this. So first I'll just start with the code from the previous video. So I've just taken the same code, I've removed the ball. So we only have the table and just the simple rectangle. So you'll also see I've done some small changes here. I'm no longer using the other SDL2 package because actually when you use the package like this, we need to call, you can basically call those functions directly without using this SDL2 prefix. Because we've not done that, right? Because I have not used any SDL2 method like that. I have explicitly used SDL2 every time. I don't really need this over here. And what you do on top of this here is the quick load to actually load the package directly. So this is a new package. We will see about this later, but this is the base and we can get started with this. So I already have it loaded. I can just compile this again. And if I'm in the loop, we'll have a simple rectangle like before, nothing special. So now I have actually added a sprite to this basic rectangle. So how did I do that, right? So I have the code here already, but I'm going to tell you how I approach this. I literally went and searched how to draw a sprite in SDL, and I got this AI generated response. Now, basically, this is for the core SDL library within C, but that's okay because the common Lisp API would be identical more or less, right? So you see here, it looks like you have to load an image as a surface, and then from the surface we create a texture, and then the texture is used later. We can throw away the surface, and then finally to actually use the texture, it seems we have to do a render copy from that texture's source rectangle to a destination rectangle, right? So this seems to be the basic logic, and that's nice. I have not done something like this before. I am just figuring this out along with you. So so my first problem is I don't have a sprite. So I just searched for online open sprite websites and I got this, which looked nice and cute. So I wanted to use some version of this sprite. Now again, this is, I have not really done something like this before. So I just downloaded this file and I opened it to see what it looks like. And you see that there is a bunch of different images which can be put together to get your animation going. So I'll just start with the simple thing. Let's focus on this one image and let's try to render it, and let's worry about animating stuff later. So this image, so if I look at this, if I just do like this, I see that the image is 320 cross 320, and if you see here, there's exactly 10 of these images, 10 cross 10. So which means our each of our source images is 32 cross 32, right? That's good to know, because if you see in this code here, there is a source rectangle where you have your width and height of the sprite, right? And I didn't know that, but now I'm going to guess that's 32 pixels. So I've done the exact same thing. So what I've done is I have in this core render loop, I am loading the image. So there is one more thing to note here. I saw that this version was PMP and I tried to use this API. It exists, but then I couldn't load a PNG, and our sprite is in PNG format, right? So then I did another search and I found a blog here which talks about how to use PNG images with SDL, and it seems we need to use a different library called SDL underscore image. No worries, this is also there on Quick Lisp. We have a common Lisp wrapper. So the function is slightly different. There is a load texture here, right? And so I just figured this out. I didn't even search any documentation. I just figured this out like with trial and error. So what I mean is, if we have the SDL2 image thing that is loaded, and then I just hit autocomplete here and I get this, and I know we have a PNG file, right? So this seems to be the relevant function. Like I don't even know what RW stands for. Maybe read write, I don't know. But this seems to be the closest function, so I just used that and it worked, right? So this is literally me doing trial and error. We don't really have good documentation or something to follow, but it's okay. Common Lisp is discoverable. We can do these things and we can keep proceeding. So we have done this to load the surface, and then we used this create texture from surface. Again, used autocomplete to figure out what is the name of this function, because the C version that you see here is called something else. So here it's create texture from surface. It's basically using your camel case, and but that's not true. In Lisp we use this kebab case, so it's like this, but that's okay. Use autocomplete, figure it out, right? And then we free the surface because we don't care about it. And then now I'm going to pass this sprite sheet, that's what I just called it here, to this function draw. And earlier we didn't have that. So now we have one more function here which is going to just draw sprite at a particular location. For now I just picked 300 comma 300. And if you look at draw sprite, it's the same render copy that you see here. So we're going to do render copy, the renderer, source, and then the rectangles, right? So the source rectangle is going to be 0, 0, 30, 32 because that's the size of a pixel, and we are going to just place it as it is at x comma y, the same size. So I had some trouble getting this working because initially I got an error that the wrong key was found. So then I was confused if the render copy function was right. So then what I just did was I just looked up that function in the CLSGL2 library, the common Lisp wrapper, and you see the render copy function here. And I could see here that this key, this basically these arguments are to be passed as keyword arguments. So you can't directly pass them. Maybe they might have been an easier way. Actually, it shows here also the documentation. It didn't immediately strike me, but that's the simple thing to do. Again, you don't have to leave Emacs to do these things. If you just, it literally shows you that the arguments after this are keyword arguments, so you need to use this syntax. So if you remove this and do it, it will not work. So this is the basic thing. So if I compile it and run it, we have our character show up here. Now it's very small, and so why don't we scale up the character? So what I mean is, again, yet one more beauty of Common Lisp. So if I go here to my code and say just double this, so this is our destination rectangle where we want to split it, and we are now like doubling it from 32 to 64. So if I just recompile this, you see that immediately the change has shown up on the screen. Let's double it again. So if I make this 128, 28, recompile, and that's a lot better. You can see our character nicely visible on the screen. So the loop is still running, nothing has changed, but every time, every 220 milliseconds or whatever, when this function is called, I have just recompiled this and the change is visible immediately. So if I, let's say, make this something like this, that will squash our character. Not nice. We want the clean ratio to be maintained, and you see the updates are immediately visible. So before I proceed to the actual animation, I want to clean up the code a little bit to put our sprite into a separate class and manage it. So earlier we had used structures. This time I'm going to use a class because it's easier to update things and so on. So if you see here, I've created a new class, hero, and I have put in the position X and Y. So we have set an init form, so init value to be like 300 random, and we also given an accessor X and accessor Y to be able to access, set, get, all of that, right? And then I'm also adding our sprite sheet representing the character, and I don't have an initial value. Instead, I have an init arg, so that will set. We can use this now to set this value when you create the zero object. And we have our accessor also for this to be able to set and get. So we introduce this into the loop here. So if you see here, once I create the texture, I now also create the hero instance. So I use make instance of the class name and then pass the surface, right? The texture in. So that makes that hero character ready. And I'm going to pass now this hero object to the draw function we had earlier. So that's where this is getting passed here. And earlier we drew the sprite here. Now we will instead draw hero, use the draw hero function and pass the hero and the renderer, right? One more thing to note here, I have just changed that sprite drawing code into this function, and it may be interesting to note I have used the fun and not def method, right? So specifically in this example, I am not using the method and the full hierarchy of class, methods, and generic functions. Instead, this is a normal function which is taking a hero as the first parameter. So this is just a stylistic choice. Basically, I want to use the clause to be able to encapsulate my fields, but I don't right now want to use the method aspect, right? So this, the fact that you have fields and you have methods, and both of these are very tightly coupled in every other object oriented programming system out there. In clause, you can kind of no, not really take in everything, right? So you can worry about these things separately. So here there is a separate function which is going to use this hero object, and I don't really need the dynamic dispatch and so on. And now here you might see one more thing that I'm doing. So this was our code initially where we did the renderer and we passed in the fields. So now if you see, we want to pass the fields by accessing it from our hero object. So ideally, I should have written this code as something like this, right? Because that's how the method functions. So if I provide an accessor SS for the hero class, then I can use SS with H to get out that SS field, right? But thanks to the beauty of common Lisp macros, we have a nice macro called with slots here. So what we're saying is we want to pull out the slots SS, X, and Y out of this object hero object H, right? And then the rest of the body, wherever these variables occur, these symbols occur, they will resolve to those accessor fields. This means I can directly use a slot, I can do set, get, and so on. I would not be having to write that code separately. It just makes my code easier to use. So nothing has changed. If I rerun this, if I compile and rerun this, nothing would change. It will look exactly the same. But this is just structuring so that we can do the other things that we want to do in an easier fashion. So now I add the first basic version of animation. So what I've done is I have added two fields here, a tick and a speed, to control the updates to our sprite. And in our update, we basically just keep increasing tick until we reach the end of our set. So basically what we're saying is we have like period. So this is less of speed and more of period. So if that's 4, then after every 4 ticks, we will update our image to the next sprite in the list. And we actually have 10 different sprites, but I'm setting this overflow to 9 so that the loop is more smooth. I added to 10 in the starting, but that led to a bit of a flicker at the end. Once you have this update, now when we draw the sprite, instead of drawing the first image every time, we're going to look up the exact image we need to draw. So that would be like the tick divided by the period, and then just move the offset by 32 pixels, and we have our location from where we get the source image. And once we do this, you will see our little sprite being animated. This is very nice. You can see the dagger moving and the cloak and the face moving around. So this is our first level of animation. So if you see in the source data, there are other animation sequences there for like basically for moving around and so on. Let's see if we can maybe implement one more of that in this. So the next thing I have now done is to add a little bit of user control. So basically some keyboard input. So the way we do that is basically I can show you the example here from the renderer. So you can use these sections. So there is a basically you can bind expressions for key up and key down, and based on the symbol of the key that has been pressed, you can take some action, right? So simple example here is on key down. When the key matches escape, we will simply quit. And now I added some new things here to actually enable movement, right? So what I've done is on key down, I'm basically decrementing the coordinate for left and for right. So basically left arrow and right arrow, we can now change the position, the X position of our character by 5 pixels every time. And also if you see when you do key up, we have some extra code here. So why is this? Because I wanted to bring in the animation. So what I mean is if you look at the images we have, so the first row was basically idle animation, but the third row here is about animating movement of the character as a character box. So if you see, we want, what we want to do is we want to play that sequence of animation, the third row. That means we need to change the Y offset now, and we are controlling that with mode. So I'm having a very simple version here. This is not the best way to do it. I want a simple thing to get started out with. So we have 0, which is the first row for idle movement, and we now can set this to like something like 2 for the walking movement. So what we've done is the draw will simply use the current mode, which will be saved in the hero object, and animate those sequence of images. And the now to change the mode, we are going to use our keys. So every time there's a key down, we're going to go into walking mode, and we're going to come back into idle mode when your key when your key comes up. Okay, so if you look at it now, so if we start out, the character is idle, so it's looking around. So if I start pressing the left right arrow keys, you can see the character moving. So if I press the left arrow, you see it's a bit weird because the animation is moving backward, right? I mean, the character is walking right, but the sprite is moving left. We'll deal with that in a moment. But if I press right, you see a very nice satisfying walking animation. So there's a small bit of white thing that shows up. So I thought there was a bug on my end. Like you see, there is a white bar that shows up right there. But I just realized that it's actually a problem in the source image. So if you see in the sequence of movement, this version here, right here in the cloak, there is a bit of a white line. So that's what really is showing up. You can think of that as like light if you want, or we can fix it in the source image. But so that's our basic version of animation. Let's just add one more thing here before we call it a day, and that is to actually flip our texture. So to do that, I've just again gone out and did a quick search how to flip a sprite in SDL2, and I'm getting some again AI generated answer here. It looks like there is basically render copy ex version of the function, which also takes the flip dimension. So we are going to try this. So after a few minutes, I am done with that. So like I mentioned, I was going to use the render copy X version. So if you like see the signature, you see apart from the things we had before, the source and the destination rectangle, we also have angle, center, and flip. And what we actually need is flip, like we saw in the answer here. So basically we need to, sorry, here, where we need to set the flip to horizontal or vertical. Now, for a moment, I was a bit confused how to do that in Common Lisp because I couldn't find in the repo the exact flag, and I couldn't find it with autocomplete also. But when I searched the repo, I did find one issue which talked about this, and turns out they have implemented it as a list of symbols. So what we are doing here now, I am going to have a new field called direction, which is set to default. So this is just the symbol right, and we are going to then have accessor to set this. And like you would expect in our main function, when we have the key down, basically when we have the direction left or right, we're going to set the direction over here, right? So again, all of this can be cleaned up, but for now just work with this. We are going to set the direction to the left symbol or right symbol. Now that's okay, but when we draw, we need to be able to use this field. And what we're doing is basically we need to set the flip keyword argument, and if the direction is equal to left, we're going to flip the sprite horizontally, and otherwise we are not going to do anything. And this has to be a list. So basically from this issue here, I mean, I just logged out that I got this one issue with these details, but it has to be a list of these keywords specifically. You can also flip like both horizontal and vertically and so on, but we just want this horizontal flip. And with this also in, you see now character moving right and also character moving left. You see it's way more natural. So if I just click once right and left, you see the character turning between directions. So that's basically the sprite being replaced, essentially flipped horizontal, right? That's great. This is amazing. I've never done anything of this sort in any other language. So this has been a very fun video to put together. Now again, my mind is like teeming with ideas on how to use this. We can go into a proper game with collision detection, with the things we have seen before, with the ball flying around, and with this sprite. Now that I've done this sprite once, I can add more sprites, more objects, build a full 2D game. That is like a very interesting angle to pursue. I don't know if I'll do that right now. Maybe we'll do that later in the Common Lisp series sometime. But for now, this is it. A nice animating sprite with moving around and animation, different animations for different modes and so on. I don't think we did any complicated things in this video. This is all very common use of ordinary things. We have learned how to use the SDL interface a bit more. For example, we have done key key manipulation, keyboard sensing, and we have maybe we've used clause object for the first time. And I think everything else is pretty ordinary stuff, nothing special. We're just flipping through images to the animation. So, but yeah, that was a fun video, and let's see where we go next.